Right, this is Juno 1 AS1, and this was a very long synoptic style question where you had to answer your answers in an answer booklet and just write the question number and so on. And this includes a whole lot of equations and motions, so I'm just going to do the whole thing. There's a projectile question at the end. So I'm going to do this on a white sheet of paper. A vehicle on a straight road starts from rest, accelerates at 1.5 meters per second squared for 20 seconds. It then travels for 200 seconds at a constant velocity and finally decelerates uniformly, coming to rest after further 30 seconds. Sketch a velocity time graph for the whole 250 seconds period. Label the velocity and time axes with appropriate values. So if we just take this away again, so this is 7a, and it's part 1. So we need a velocity time axis for 250 seconds. And it goes up to 250. And so if I just split that up there, into 50s. Roughly. 250 is a wee bit long, but... Right, so you're told, first of all, its initial velocity is 0, and it accelerates uniformly for 20 seconds. So I'm going to call it three-part. This is part A. Its initial velocity is 0. Its acceleration is 1.5 meters per second squared, and the time is 20 seconds. And we want to calculate its final velocity at the end of that. So V equals U plus AT, which is equal to 0 plus 1.5 times 20. And V comes out there to be 30 meters per second. So that's the first part of the motion. That happens in the first 20 seconds. So there's about 20 seconds there. And so it goes up to 30 meters per second, say. And so that's the first bit of the graph, part A. And there's your first part of your graph. Second part of the graph then, it continues, travels for 200 seconds at a constant velocity. So V is equal to 30 there for 200 seconds. So that takes you up to 220 seconds. And so if that's 50, 100, 150, 200, so about 220 seconds is about there. And that's going to be a flat line, a straight line. And then the last part of the question says it then comes to rest, decelerating uniformly in a further 30. So you don't need to calculate anything there, it's just coming to rest in a further 30 seconds, which takes you up to 250. And that's the shape of your graph. So part C, V goes from 30 down to 0. Right, the next part then says, find the total distance travelled. And the total distance travelled is the area underneath the graph. And then hence calculate the average speed for the whole journey. So you've got 3 parts to the graph. And I'm just going to call them A, B and C again. There's the third part there. And C. So the first one, the area of A, is going to be half the base by the height, and half the base by the height is half by 20. We look at that by 30. And that gives you 300 meters. For B then, the area is just the length by the breadth, which is equal to 220 minus 20 is 200 seconds multiplied by 30. That gives you 6,000 meters. And then part C, just look at it again. Again, it's a triangle with a base length of 30. So A is equal to half base by the height, which is a half times 30 times 30. And that gives you 450 meters. So the total distance is equal to 6750 meters. Okay, that's part 2. And then part the second part of that question asks you to calculate an average speed. So the average speed is just the total distance over the total time. And that's 6750, and the total time is 250 seconds. And that gives you an answer of 27 metres per second. And that's part 2. Part 3, sketch a displacement graph for the whole 250 second period. Now, part A, it is accelerating uniformly. And accelerating uniformly then is an upward curve. It doesn't tell you to put displacement values on, so we don't have to do that calculation. So part B of the graph then has got a constant velocity, and a constant velocity then is that takes you from 20 seconds to 220. And a constant velocity and a displacement time curve will be a constant slope, upward slope. And then part C, this time the displacement is still continuing, but it's slowing to rest. And that means this time it's a curve, but it's a downward shaped curve. As in, it's got this shape of a curve. I suppose you should say it's a curve of decreasing slope, maybe is a better way of putting that. And that takes you from 220 seconds up to 250 seconds. So we'll just draw that. We don't need to put displacement values on, thankfully. Otherwise we'd have a few more calculations to do. So again, there's 100, 250. And there's our 20, and there's our 220. And so the first part of part A is just an upward slope like that. Part B then is up to 220 there. It's something like this here. And part C then is a downward slope, or slope of decreasing gradient, but it's still going upwards. Something like that. Okay, so that's part A, B, and C, and that's displacement in metres and time in seconds.